All right, good morning for you, Algebra 1. Sorry I'm not there today. Long story short, wife had a fairly routine procedure done yesterday, and I am staying home just to make sure she's okay for today. But I will be back tomorrow unless something crazy happens, but I don't foresee that. Things went well. Everything's good. Um, yeah, You're watching this with Miss Grismer, and yeah, we're gonna talk about the quadratic formula. Now, I told you guys there was a song that went with this, and I'm not gonna do that to Miss Christmas. So, we will do the song together tomorrow. But today we're gonna learn the quadratic formula. Tomorrow we'll dig into kind of the when you do what's of solving quadratics, and that's gonna be how we finish the semester and the year. Okay, so the quadratic formula. This is our last method that we're going to talk about for solving quadratics. And I call this the silver bullet. And I call it that because this will always, and I do mean und always, work. You can always solve a quadratic with this, even in the future when it has imaginary roots. Okay, this is a bulletproof method. All right. So the steps to solving this, pardon me, are similar to when we factor in the beginning, and then quickly crosses over into basically just plug and play. We're going to identify some values, plug them in to the formula, and calculate, and that's it. So you'll see on my screen in front of you, you should be noting that I have my calculator up, so you're going to probably want yours out. If you don't have yours, share with a buddy. You're going to want a calculator for this. Oftentimes, you can do the calculations in your head, but it's helpful to have a calculator to simplify the process a little bit. So we'll go ahead and do these. I'm not going to do all of these samples down here. I'm going to leave some for you guys to do. I'll probably go through the odds. Sure, yeah. And then I will leave the evens for you to do in practice. And I'll do the same with the irrational solutions. I'll probably do at least two of those irrational solution ones. And that'll be it. So, okay, solving quadratics with the quadratic formula. So you'll see over here on the left-hand side is our quadratic formula. So you'll see all of this shenanigans right here. That is the quadratic formula. Now, for those of you who have been paying attention, some of this should look familiar, okay? We have already, trying to get my pen pencil back. It's not working. There it goes. You should remember x equals opposite b or negative b over 2a as the axis of symmetry equation. And you should remember b squared minus 4ac as the discriminant, right? You mash those two things together and you get the quadratic formula, all right? And so you'll see it's negative b plus or minus. That's because of the square root, right? We don't know what that root was, and that'll be how we produce our two different answers. So plus or minus the square root of b squared minus 4ac all over 2a. And yes, there's a song for this, and yes, we will do it tomorrow, I promise you. I won't let you finish the year without learning how to sing Pop Goes the Weasel to the quadratic formula. Okay, so to solve, step one is get it equal to 0 and in standard form. You should remember that means descending in alphabetical order of variable and power, right? So most of these are all going to be in x, but so we don't have to worry about the alphabetical thing, but we do want it in descending order of power. So I want squared to the power of 1 to the power of 0, right? So let's go ahead. So that's already set up. This one is already the way I want it, right? If you don't remember, standard form is ax squared plus bx plus c, all right? X squared and x are the variables we expect to see. A, b, and c are numbers. And for the quadratic formula, you will notice that a, b, and c all appear. We need to know what all three of those values are. So step 2 is identify your A, B, and C, okay? And I typically like to write that out, so off to the side somewhere, I'll say, hey, my A is, in this case, it's the coefficient of x squared, so it's just 1. My b is the coefficient of the x term, which is -5. And my c is whatever my constant is there at the end, which is -36. Make sure you keep the signs that are in front of them with the term, right? So if it's positive, it's positive. If it's negative, it's negative, all right? So you now know all three terms. Literally, you're just substituting in. Where you see B, you're putting the value you have for B. Where you see A, you're putting the value you have for A. Where you see C, you're putting the value you have for C. If there's a negative or a positive present in the formula, it stays there. Your negative goes into the substitution, right? So let's see what that looks like. X equals, it's negative times B. Well, B is -5 plus or minus the square root of -5, I need to save room, squared, minus 4 times A is 1 and C is -36. Okay, there you go. All right, that is the top, all right? And then we go over 2 times A, so 2 times my A value is 1. All right, now typically what I will do is in my next step, I will go about doing some of my simple calculations that I can do. So like this negative times a negative. So this is going to become +5 plus or minus that -5 squared is going to become 25. And then we can say -4 times 1 is -4 times -36. Here's where a calculator comes in handy. So I could say -4 times -36, right? And it's going to give me 144. So 25 minus, 25 plus, because it's a negative times a negative, so 25 plus 144 over 2 times 1 is 2. Okay? And we would say 5 plus or minus the square root. 25 plus 144 is going to get me 169 still over 2. We know the square root of 169. Hopefully you remember that is 13. So we would say 5 plus or minus 13 over 2. And this is going to produce your two answers, right? So we would say equals, and then so we're going to say our solution set, right? So this is all x equals, right? Our solution set, so if we were to add the 13 to be 5 plus 13, we would get 18. 18 divided by 2 is going to be 9. That's my positive value, so we'll put it over there. If we were to do the negative, right? Oops. Okay, so I can't do that way. 9. If we were to do the negative direction, right? We would get 5 minus 13, which is going to be -8 divided by, so we get -8 if we subtract the 13 divided by 2 is going to be -4. And that's it. Okay. For these kinds of equations that give us real clean whole answers, the quadratic formula is not the best method. There's faster ways, but it's a good way to learn. Okay. It's a good way to learn. And that's what we're here to do, right? We're going to learn it this way, and then we'll apply it to the ones where it actually is helpful. And you'll see those at the second half of the notes here. Okay. So, number 1, we're going to party through this, okay? I got to get it equal to 0 first. So you'll notice we're not equal to 0, so we need to subtract the 20 from both sides, right? Doesn't have any like terms, so you're going to end up with x squared minus 8x minus 20 equals 0, all right? Cool. Now we can use the quadratic formula. Identify your a, b, and c. So I know my a is 1, right? Coefficient of the x squared. My b is -8, and my c is -20. Okay, so I've identified my a, b, and c, right? It's my a, my b, my c. I'm ready to plug into the quadratic formula. So x equals negative times b, which is -8, plus or minus the square root of b squared, which is -8 all squared, minus 4 times a, which is 1, times c, which is -20. Okay. All over 2 times a, which is 1. All right. Cool. Hopefully you're jiving so far. We're going to say that this becomes, we see that top's going to become 8 plus or minus the square root of, I'll tell you now, your calculator can actually handle this pretty well. We want to do -8 in parentheses squared. If you don't put it in parentheses, your calculator will misread that negative as a coefficient, and it'll keep it negative, and it shouldn't be. And then we would say -4 times 1 times -20. So your calculator can handle this in one hit, and it's going to kick out total. So what's under the radical is just going to be 144. So we would say 100 and, whoops, sorry about that. 144 over, and it's 2 times 1, so it's 2. Okay, so this becomes, again, this is all x equals. This becomes 8 plus or minus 12 over 2. Okay, 8 plus or minus 12 over 2. Therein lies our two answers. So if we do the subtraction first, so we would say 8 minus 12, -4 divided by 2, -2, right? And then the 8 plus 12, 20, divided by 2 is going to be +10. If you're not getting where that's coming from, I'm doing this plus or minus, right? I have to do both situations, right? So 8 plus 12 divided by 2 and 8 minus 12 divided by 2. That's what I'm doing. Okay, I'm doing it in my head real quick. So the 8 minus 2 is -4. -4 divided by 2 is -2, right? And then I do the plus. 8 plus 12 gets me 20. 20 divided by 2 is 10. That's where the 10 comes from. Hopefully that sticks. Okay, you have to do both iterations and know your calculator can't do both at the same time. All right? Okay? Okay? Cool? Everybody happy now? Having fun? I know you are. I know you guys are having so much fun. I know you are. I can feel it. I can feel it. All right. Okay. So this one's unique. And so I like we run into unique ones. You can be missing terms, right? So you'll notice this one, again, standard form is ax squared plus bx plus c. This one doesn't have the bx term, right? And typically I would tell you, hey, don't do the quadratic formula with this. But again, we're gonna do it for the sake of argument, that to show that it does indeed work with everything. So we would say my a term is 3. My b is actually 0. Just because it's not there doesn't mean it just doesn't exist. B is 0. 0 times x is 0. We don't write plus or minus 0, right? And my c is -12. This one's already equal to 0. I don't have to worry about any of that shenanigans. Okay? So we would say x equals opposite b, which is 0, plus or minus the square root. That's not very big, is it? I'm making it really small. The square root of b squared minus 4 times a, which is 3, times c, which is -12, all over 2 times a, which is 3. All right? So we'll do some simplification. That 0 out there is completely unhelpful to me. I don't need to write it. So we're going to just lead off with that plus or minus the square root of whatever happens down here. Well, the 0 squared is, again, irrelevant. It's 0. So we're going to say -4 times 3 times 12. And -4 times 3 is -12. -12 times -12 is going to be positive 144. We've got a lot of those happening today. And 2 times 3 is going to be 6. So then this is going to become plus or minus the square root of 144 is 12 over 6. And therein lies our two answers, right? Positive 12 divided by 6 and -12 divided by 6. So x is going to be, the -12 divided by 6 is going to be -2. And the positive 12 divided by 6 is going to be +2. You can also write this as x equals plus or minus 2. Whoop-hoo! We're having fun now, right? I know you guys are. Again, I know you guys. You guys just, you eat this up. You're so just, like, it's riveted right now. You're enjoying every moment of your life, and I can tell. I can feel it. All the way over here, I can feel it. I can feel it. Okay? All right. Number 5. Number 5 is interesting because we have ourselves a negative leading coefficient, which I told you guys historically you want to avoid. But guess what? I told you the quadratic formula works no matter what. The quadratic formula works no matter what. Can even work in this situation, right? So you'll see leading A is a -1, right? So we're right out of the gate. We're saying A is -1. We're saying B is -10. And we're saying C is -21. I'm running out of room over here. We're going crazy. All right. So with that, we're ready to plug in, right? So we would say x equals -b, which is -10. So negative times -10, plus or minus the square root of b squared, so -10 squared, minus 4 times a, which is -1, times c, which is -21. All over 2 times a, which is -1. Okay. We can do some quick arithmetic here. The negative times the negative at the lead up there, that's going to become +10 plus or minus the square root. What's all that shenanigans become under there? Again, so parentheses when you're squaring a negative number, -10 squared, right? Which, if you know that's 100, just plug in 100. But I'm trying to throw you guys a bone here to show you that this does work in one shot. Minus 4 times -1 times -21, right? Click enter, and that whole business comes out to +16. So square root of 16, right, over 2 times -1 is -2. Okay. So we would say then that 10 plus or minus the square root of 16 is 4 over -2, right? And now we're ready to calculate, right? So x equals, let me see, 10 plus 4, that would give me 14. And 14 divided by -2 is going to be -7, right? And then 10 minus 4 is going to be 6. 6 divided by -2 is going to be -3. And those are your two solutions. There you go. Ta-da! The quadratic formula. Bulletproof. It always works. Okay? It always works. All right? I'll skip number 7 here. It's more of the same. The big thing here is trying to trip you up with having variables on both sides. Just get them to one side. In this case, I would go this direction, right? So I would subtract the x and add the 10, right? So you end up with x squared plus 6x plus 10, okay, equals 0. And now you have a quadratic that's set up to solve. That easy. It works. Actually, come to think of it, I am going to finish this one. I take it back. I'm going to finish it. I just looked at how this works out, and I realized it's important and we need to do it. So let's finish it out. So we would say A is 1, B is 6, C is 10. Okay? C is 10. So we're going to do quadratic formula, right? So x equals opposite B, so negative times 6, plus or minus the square root of B squared, so 6 squared, minus 4 times A times C, which is 10, all over 2 times A, which is 1. Okay? So this would become -6 plus or minus the square root. You see, 6 squared is 36. So 36 minus 4 times 1. I shouldn't have done that. That's not necessary. Times 10. -4. Okay. -6 plus or minus the square root of -4 over +2. Now, from our lesson the other day of solving by taking the square root, you should notice something. We have a problem here. And the problem is we are trying to take the square root of a negative number, right? There is a way to solve these, but you guys don't know it yet, okay? So for the purpose of where you guys are at, you would say that this is no solution. In reality, there's no real solutions, okay? But telling me no solution on one like this is appropriate at this level, okay? So we would say no solution or no real solution is available for this because we can't take the square root of that negative number, all right? It doesn't work. Okay. All right, what are we at? 20 minutes. Okay, I'll do probably 2 more of these irrational solutions. And the rest of the class, you are expected to do work your way through these evens. I would say probably do a couple of the ones up here, get warmed up with it, and then do a couple of the irrational ones. That'll be good to get you warmed up for tomorrow. All right. Irrational solutions. Again, what happens with this is when we have radicals that don't simplify, that we can't take the square root of it. And it's not because it's a negative number and it's impossible. It's because it's not a perfect square. So we were left with an irrational value, right? So looking at number 1, it's already in standard form. We're ready to party. We're going to say that A is 1. We're going to say that B is 4. And we're going to say that C is 1. Okay? So we would say x equals negative b, so negative times 4. That's a terrible parentheses, I'm sorry. Plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. Okay? So we would say x equals negative 4 plus or minus the square root of 16 minus 4 times 1 is 4. So it's going to be 16 minus 4, which is just going to be 12, all over 2. Okay? All right. So you have a situation here because 12 isn't a perfect square. All right? Hopefully, again, you remember back to your pre-algebra days on how to simplify basic radicals, right? We want to split this up into 2 radicals. First one's a perfect square. Second one is not. They multiply together to be whatever you're starting with. So this would be 4 and 3, right? 4 is a perfect square. 3 is what's left over. And 4 times 3 is 12, right? So the square root of 4 would be 2. So we would say x equals negative 4 plus or minus 2 root 3 all over 2. Okay? 2 root 3 all over 2. The one thing to check with this is whether or not what's down here can divide your number and coefficient evenly, right? Can't divide into the radical with it, but you can divide if the radical has a coefficient in front of it, you can divide that with your denominator down here. So 4 and 2 both divide by 2. So we would do that, and our solution is going to be negative 4 divided by 2 is negative 2 plus or minus 2 divided by 2 is 1, so we don't write it. So negative 2 plus or minus root 3. The plus or minus is our 2 answers, right? That is as far as you can go. We can't combine those. That irrational value is in its most complete state when I leave it as a radical. If I try to write it as a number, I'm going to have to round and I'm going to create an error. So we're not going to do that. Not if we don't have to. Okay? So there you go. This is where this right here is where the quadratic formula shines. Okay, this is where it shines. This is what it's good at. It's good at solving trinomials that don't factor, because this wouldn't factor. Okay, so you'd find yourself scratching your head of, what do I do with this thing? I can't factor it because it has a bx. I can't take the square root. You could put it in your calculator and graph it, but you're going to get some wild decimals, right? And you're going to round and create error. This right here, the quadratic formula, is the most accurate way to produce this answer, all right? And it works every single time, okay? Every single time. I'm going to skip down number 13, actually, just because it poses a different challenge from what you guys have been seeing so far. So 13, you'll see I have x squared on both sides. Oh, no. What are we going to do? Oh, no. Just get them to one side, all right? Since I've got a negative 1 on the left, I'm going to move everything over that way and keep it positive, okay? Doesn't matter in the quadratic, but it's just the smarter thing to do if you have the opportunity. So I'm going to add the x squared to both sides. I'm going to subtract the 8x from both sides. So this gets added here. So I'm going to end up with 2x squared. And then the negative 8x doesn't have any friends, so it just is negative 8x. And then the plus 3 doesn't have any friends, so it's just plus 3 equals. We've now made that right-hand side 0 in one foul swoop. Okay? Now identify my A, B, and C. A is 2, B is -8, C is +3. All right. And now we plug in and we go. So we would say x equals opposite b, so negative times -8, plus or minus the square root of b squared, so -8 squared, minus 4 times a, which is 2, times c, which is 3, all over 2 times a, which is 2. Okay. There you go. So let's boogie. Let's see what we get. Again, x equals negative times negative is going to be positive. So we're going to have +8, plus or minus. We can leverage our calculator on this one. This one's got a little bit more going on to it. Not too bad, but just for the sake of insurance. -8. We don't need to do that. -8 squared minus 4 times 2 times 3. They're all positive. We are going to get 40. So we're going to get the square root of +40. So we're going to get real solutions out of this over 4. Okay? Over 4. So let's simplify that radical, right? We're going to break that radical, that 40, up into two different radicals. We would say, oh my goodness, sorry about that. That was completely out of pocket. We would say what two radicals, right? Does this kind of break this into? And right out of the gate, I know 4 and 10 would probably be my best guess. So I would say square root of 4 times square root of 10. Remember, those multiply to become 40, and the first one is the largest perfect square that I can evenly divide out. So, and we would know the square root of 4 would be 2. So we're going to say 8 plus or minus 2 root 10 over all over 4. These all have a GCF of 2. So 8 divides by 2, 2 divides by 2, the 4 divides by 2. So my solutions are going to be x equals, and we can put it in solution set brackets. We would say, all divided by 2. So 4 plus or minus root 10, because 8 divided by 2, 4, 2 divided by 2, 1. Don't write coefficients of 1. All over 4 divided by 2 is 2. And that is it. That's all there is to it. At this point, I want you guys to do, I would say with the time you have left, you should have time to do 2 from each section. So 2 from 2 to 8 and 2 from 10 to 14. Okay. If you guys struggle with simplifying radicals for this year, I will give you a break and accept that answer. But just know that next year I'm coming after you. And if you know how to simplify them, simplify them. But I know not all of you have gotten exposed to that. So and we didn't get to that unit this year, which is expected. It's not common you get to that in Algebra 1, at least not in my experience. So, yeah, that's cool. But simplify if you can simplify. Okay? But other than that, get after it. Love you guys. Hope you're having a good day. Stay strong. Hey, we're in the final stretch. You got 2 weeks of regular classes left, finals, and we're out of here. Okay? Stay strong. Finish strong. Finish with some honor. Okay? I will see you guys tomorrow unless the world burns, and I certainly hope not. Peace out, guys. See you tomorrow.